Announcing the world release of the Wood Gasifier Builder's Bible on September 15, 2014. Learn the lost art of turning wood into motor fuel using tree branches from your own property. Power your life through any crisis in total comfort. Cut your energy bills or just go off the grid completely. Today we have a special sneak peek of the book, build footage, and demonstration of the gasifier in action. Now, meet the author, Ben Peterson.
Hey guys, Ben here. It's coming, the Wood Gasifier Builder's Bible. If you don't know who I am, my name is Ben. I built all sorts of these wood gasifiers. They're just a super cool technology. And what I did is I took the gist of everything that's good and simple and works, and I put it in a step-by-step design that takes the classical gasifier design and pays it full homage, but brings it forward, makes it modern, makes it better. It's nice, and it's DIY, simple, DIY pricing. I've progressed my work, kind of beyond the DIY scape, so that's not where I'm at right now, full disclosure. But I did want to leave something really awesome behind. And so if I wanted to build a gasifier for next to no money, this is the gasifier I'd be building for myself. It's a little tricky to build a really good wood gasifier, especially when you're starting out. There's not a lot of great step-by-step how-to information for a modern build. And technology has popped up time and time again to save mankind, in our darkest hours during World War II, during the Great Depression, when we were industrializing, wood gasification was right there with steam, helping push that. So we wouldn't be where we are today without it. In fact, some of the first spark-ignited vehicles were made to run on wood gas, town gas, hydrogen gas, whatever. There's lots of different names for it. It's like the secret energy with 1,000 different names. But what I wanted to do is I wanted to put my knowledge in here and pass this down, make this available to you, so you don't have to scrape and struggle and go through any of the frustration that a lot of people go through and spend the extra money. I know there's free plans out there, but time and money wise, it actually costs more in the end to use free plans. I started that way myself. You're welcome to go that path if you like, but for $50, it's kind of a no-brainer. Even if you can't build one right now, this is the type of book you want to have on your shelf. This will be worth its weight in gold in the future. I can almost guarantee you that. I remember when I became a wood gas believer, it was the winter of 2008. It was the worst winter you've ever seen in the Northwest. Everything in my area was flooded, the freeway was closed, and it froze over. We had no power, no water, can't get to the gas station. The gas station couldn't even pump gas if they wanted to. And it was really like one of those storms of the century. You see on the news, it's always happening to somebody else. And it happened to us. And what saved my bacon, and like I said, what made me a believer was I had this, gasifier contraption. I'm about a year and a half into it at this time. And it's making, pretty good gas. And I had this old Lincoln welder generator. And I had that thing fueled up, and sure enough, I was able to power, heaters. I was able to power my shop during the day. And since I couldn't go anywhere to get fuel, I literally only had wood. I had piles and piles of barn wood. And that was the right tool to have it at that exact moment. After that, I was hooked. I was like, I don't think I've spent a day not doing this since, because it was such a powerful experience.
So, what is a wood gasifier? Well, what it is, it's your own personal refinery. But instead of refining crude oil like the big guys, we refine wood into a really nice biohydrogen gas. So that's what a wood gasifier is. They've been around for about 150 years in some form or another. So what are you going to do with all that gas? You can make so much really nice, high-quality gas. What are you thinking about doing with it? So how does this thing work? It's a great question. It works on a process called thermal distillation, meaning when you heat things up, they change phase from a solid to a liquid to a gas. And so what a wood gasifier does is it just phase shifts the wood when it's cut to the proper size like you saw in that picture, and phase shifts it into a really high quality gas. What's really remarkable about the way this process works is that deep inside the machine there's all this charcoal being formed, and there's air jets blasting into it. And it creates a singularity, this hot point of energy, that's 2,000 to 3,000 degrees Fahrenheit. And so it's really changing the molecular chemistry of things at that temperature as the gas passes through. It's a very clean distilled gas. It's really amazing. So here's the quick history on wood gasification. There were some experiments going back to the 1600s, but in about 1859, I believe it was, Siemens patented a really stout commercial gas-fired design, and that's what really kicked it off. By the turn of the 1900s, there were about 12,000 gasifiers in North America. They powered America through the 20s. When the Depression came, wood gasifiers were powering people all over the world. And then after that, it was World War II, where 1 million gasifiers strong were installed and operating all sorts of stuff: tanks, cars, factories, you name it. Anywhere they would have used petroleum, they had a wood gasifier. Had a nice resurgence in the 70s, and just here again recently with the financial collapse in 2008, again renewed interest. It's one of those cool technologies. It's always there waiting for you. But since the emergencies that people are responding to are several decades in between, the knowledge tends to be lost in between cycles. And so one of the things I wanted to do with this book was to put all that knowledge there so you didn't have to repeat all of my struggle and mistakes.
So the World War II gasifiers are known for saving the continent and doing lots of great stuff, but they also had some design issues as well. One of them is, they bled off a lot of heat. And they had to do that because they were limited on space and weight and resources. But it's really a good idea, instead of bleeding that heat off, because those gasifiers were as hot as a wood stove, we've actually insulated this in several different ways to capture that heat so we can convert the wood even faster. Another issue they had was bridging. The feedstock would get stuck in this area because the oils would release and then the wood would stick to it. So by running this hot gas around the outside here, we're melting off any oils and allowing everything to turn into charcoal so much sooner that it's actually able to convert into higher hydrogen, and it really eliminates a lot of that bridging, that's fuel not falling down. Another thing it does is it allows us to tackle wetter fuels. Some of the World War II gasifiers were known for only being able to run wood-dried, oven-dried wood blocks, and that's not known by everybody, but some of those designs were really made just for oven toasted wood. We added a visual monocle there so you can see inside, which is a nice feature. Kept a nice simplified filtration that's common. And we've installed an automation control box that controls our suction blower and our grate motor timing. Another challenge of the World War II designs was the grate would plug up with ash. What we have is an automated grate that just gently sifts the ash through and makes everything flow really nice. The World War II designs, some of them had hand crank suction blowers. Not the ideal way to start. With this nice robust 12-volt blower, this thing has a lot of suction, so it gets the machine started up very quick.
And of course, the engine air mixing controls were pretty basic back then as well. A lot of manual adjustments were made in the cab. Now we have some really nice automation stuff. And the ninth issue you get from a World War II era gasifier is tar. It's very possible that the oils you're breaking down don't get broken down fully, and so some of the oils get burnt up in the process, and they're turned into tars. And those tars can foul your intake valves in your engine and whatnot. And so by addressing all of those problems in this design and going through and systematically eliminating them, it's made for a design that's very, very, very clean. So you can really appreciate that. All right, so now let's have a look in the Wood Gasifier Builder's Bible and see how this thing was built. We've got some schematics there for you. We've got layouts and a lot of just big photos, very simple instructions that take you step by step using just local parts for the most part. Try to make it just as simple and obvious as possible. It's quality, it's nice thick metal, it's going to last you a while. But when this is done, you'll have an asset. If you follow these instructions, you'll have an asset. You see there's part sketches in there. Here's some of our table of contents. Lots of different assemblies in there, so we take you through each one. Got tricks of the trade, how to get your machine built for cheap. There's some good wisdom in there too.
So if you get the book, read the book, follow the book, you get one of these. Look at this beauty. This is totally classic invert, redone with better insulation, better heat dynamics, automation. I put a Victory grade on here, one of my really nice, great designs. It even has like a really nice viewing port here. Great heat exchange setup. It's built on a frame, and so you can roll it around. I just put wheels on it. Simple automation. The relay is probably about $100 to get the intelligent little brain for that. It's rock solid. This is just from the book. You too can make really nice wood gas. I know you want to see this thing fired up. I want to fire it up for you. So let me go get a torch and some marshmallows. So if you look inside there, you see it's just starting to warm up. But you see that molten orange, and that's our little sun forming in there. All right, this should be ready to light up. All right. Okay.
What? I'm roasting.
Looks good. So we got this thing fired up. I don't know if you can see the flame very well against the white background, but it's a nice tall flame. Ends right about there.
Here, tall.
Yeah.
Here.
Yeah. Look at that. Nice, steady, clean gas from wood. It's so cool. What could you do with clean gas in your life? You could power engines, tractors, bug out vehicles, backup generators, water pumps. You could heat your greenhouse, heat your home, heat your barn. There's a lot of cool stuff, and the byproduct of this is activated carbon, which you can actually use to filter your water. You can eat it, and it actually will help pull toxins out of your body. So there's, this is the #1 asset to own in any situation. I mean, you have your own private, distilled gas, natural gas well right here. It is super cool. This is the #1 question I get asked is, how do I convert an engine? All right, so when we're converting an engine, we have first our engine and our engine intake. Then we have a supply of clean gas. And so now what we need to do is we need to bridge those two things with some sort of carburetor, some way of mixing the air and the fuel to the perfect amount for the engine. So the brute simple approach is to run your clean gas to a pipe. That pipe runs and mates up to your engine intake. And then you tee in with another section of smaller pipe, and you put a butterfly valve there. And then you can choose the air-fuel ratio, get it set, and you'll find a sweet spot, and you can get engines to run. It's brute simple and basic. Obviously you can hook up some linkage to it, so if you're in a tractor or in a truck or somewhere, you can modify it while you're driving. So it's rock solid, it's low tech, it works. All right, so this is more of our traditional off the shelf. This is a total air fuel ratio management system by Governors of America. And this is a great setup, but it's limited to the engines that they produce it for, and so it's really like a 4-cylinder 25 kilowatt Kohler genset would be the minimum for this, which isn't a bad deal. But it controls the engine throttle, and it also controls the gas flow, and so it's a total thing. About $1,500 for this. Pretty long lead times, kind of challenging to put together, but it's definitely an option that's out there. All right, and if you don't want to do one of the first two options, what we did here was a custom setup, and we did this for the conversion workshop. All we did was we took an O2 sensor from a vehicle, we take the voltage output from it, and we run it into a little Arduino microprocessor. There's a little piece of software written, and then it just takes that code and directs this servo motor here to adjust the air control valve, and it meters the airflow and the air fuel ratio automatically. Works awesome. And you can update the code, you can do all sorts of stuff. So I'm looking forward to see what people do with this. So we did this as a part of our full conversion. We put it together in this book, the Electronic Carburetor Workshop. That's going to be coming out real soon. Might even be out by the time you watch this video. And it answers those tough questions about how to hook up your free gas system to your engine. And we make it just as easy as possible. Let's come check out some build footage from the workshop. I think you're really gonna like it when you see it in action. Question, what does it cost to build or buy one of these machines that you've seen in the videos? So basically this machine cost me about $1,500 in parts. And that's with all the tweaks on it. The simple version was about $1,200, and that was buying new tanks and stuff. If you could find, some old recycled tanks, you immediately save $200 there. It's conceivable you could maybe get down to $1,000 if you're really, like scrounging. If you had some scrap metal, maybe even a little less. If you have the parts cut, you want to add, maybe another $800 or $1,000. If you're having somebody do the welding, you want to add another $1,200 or $1,300. If you're having it done turnkey, you're probably looking at about a $6,000 gasifier. And it's just designed and built to be, that worth every penny at $6,000. We have the book for you. Hopefully you can just build it, or you know somebody who can build it. Maybe you can partner up in some way, and $1,500 in materials. You're that close to making free gas. So it's a pretty cool thing, and that's not a huge barrier to entry. We're talking about creating a mini refinery that turns wood into a natural type of gas. It's like your own little wood cartel. You're the OPEC of wood. So if you like this, We have a pre-sale special going on for the book right now. It's the best price it's going to be. It's a great book. Even if you don't use it, the book itself will go up in value. It'll be worth its weight in gold someday, I'm sure. It's very valuable information. So get a copy of the book and we'll see you during the launch. And we got some more good stuff coming for you. Thanks for watching. Bye.
Un pozo mecánico es una estructura hidráulica diseñada para el aprovechamiento de los acuíferos mediante la extracción de agua subterránea de manera racional y controlada. Para el óptimo funcionamiento del pozo mecánico se recomienda realizar un mantenimiento periódico por expertos, evitando así sufrir fallas inesperadas como problemas mecánicos, insalubridad en el recurso hídrico, bajo caudal, bloqueo en las rejillas del paso de agua, como por ejemplo incrustación de minerales, carbonatos, hierro, manganeso y corrosión electroquímica. Posterior al diagnóstico de técnicos especializados, se debe realizar el mantenimiento preventivo y correctivo del pozo. Primer paso. Para proceder a la rehabilitación se extrae la tubería, cable y equipo sumergible instalado. Siguiente paso. Se vierte el químico floculante, sustancia que coagula efectivamente y se precipitan todas las partículas en suspensión llevándolas al fondo del pozo. Luego de 24 horas de haber aplicado el químico floculante, se obtiene mejor visibilidad del interior del pozo y así utilizar la cámara de video sumergible, la cual permite analizar cada tramo de la estructura hidráulica, permitiendo ver el estado en que se encuentra el mismo y determinar la cantidad de horas e insumos de limpieza mecánica y química a utilizar. Se procede al cepillado de las secciones con rejilla para atacar la formación de hierro y dejar la rejilla lo más libre posible, lo que aumentará el ingreso del flujo de agua al pozo. Siguiente paso. Una vez confirmado el diagnóstico total del pozo, se procede a aplicar los químicos necesarios. Se necesita un ácido desincrustante y un ácido que elimine la bacteria del hierro. Posteriormente se instala un tubo con anillos para hacer efecto de succión en el pozo, a modo de dinamizar el filtro de grava. A este proceso se le denomina pistoneo. Para poder extraer todos los residuos dejados por los procesos anteriores, se instala una cubeta hidráulica a modo de llevar a la superficie el engravado alojado en las rejillas del mismo o cualquier sedimento atrapado en el fondo del pozo mecánico. Siguiente paso. Se instala un equipo provisional para poder determinar con mayor exactitud la cantidad de agua que el pozo puede producir luego de la rehabilitación, determinado en el nivel estático y dinámico. Se vuelve a inspeccionar con la cámara sumergible para observar la sanitización dentro del pozo y poder dar los resultados pre y post limpieza. Como último paso, se reinstala el equipo de bombeo sumergible en el pozo ya rehabilitado. ¿Qué se monitorea en la rehabilitación de un pozo? El pH del agua, nivel estático, el caudal, nivel de bombeo y el abatimiento. ¿Qué beneficios obtenemos? Trabajar con Aquatech pone a la disposición de los clientes personal capacitado, contando con la flota de máquinas especializadas más grande de Centroamérica, incluyendo unidades equipadas para realizar la extracción e instalación de equipos sumergibles, rehabilitación de pozos y pruebas de bombeo en caudales de hasta 2.000 galones por minuto y profundidades de 1.800 pies. Aquatech, más de 10 años evitando que se quede sin agua.
Hi. This week we'll talk about anaerobic digestion technologies and their practical operation. Remember that you can download the book for free from our webpage if you want more detailed information on anaerobic digestion. This diagram looks really scary, but don't worry, it isn't. It's a classification of different types of AD technologies. We can differentiate between dry and wet systems, between batch and continuous systems, between thermophilic and mesophilic operating systems, and between one-stage and multi-stage technologies. What I would like to go through, together with you in this module, is we'd like to look at wet, continuous, mesophilic, and one-stage reactors. The examples that we'll be discussing are floating drum, fixed dome, and balloon type digesters. Continuous actually means that we're feeding at a regular interval at the same time an equivalent volume that enters, an equivalent volume will also leave the digester. Wet means that we'll be operating with a total solid content of 16% or less, so low TS. So now let's look at these digesters. Let me start by showing you the wet, continuous, mesophilic, fixed dome reactor. This is a brick-built and gas-tight plastered structure, which is often put underground. It has an inlet pipe where the waste material is fed into the digester. It has a digester with a volume of slurry, and then it has a gas holder storage space. What it further has is an outlet, or what we also call compensation chamber, and the overflow. You might also see here that the gas pipe is at the highest point with a valve to open or close the gas flow. There are different designs of fixed dome digesters, and sizes can vary. This is the most common reactor type in developing countries. When starting the reactor for the first time, it is important to inoculate the reactor with methanogens bacteria. The easiest way to do this is by adding cow manure and water with a ratio of 1:1, or even easier, use digestate from another reactor. A rule of thumb is that it needs about 10% of the reactor volume as cow manure to start the process. But more is also fine, or even better. In this animation, we can see how this works. The waste material is mixed with water and enters the reactor and mixes with the material already in the reactor undergoing degradation. Biogas is generated in the slurry through anaerobic digestion. The gas bubbles then move to the top part of the reactor, where gas accumulates and starts to build up pressure if the valve is closed. When the valve is closed, the gas pressure will increase and push down the slurry in the reactor and up into the overflow chamber. When then the gas is used, the gas pressure drops and the slurry level balances out to a new equilibrium. Here you see a sequence of pictures of the construction of a fixed dome reactor in Lesotho during the building of the structure and the dome. Here the dome is just about finished. And here it's being plastered. This is another example from Indonesia. What you see here is that the bottom part is built with concrete and the dome part is just starting to be built with bricks. Here is a summary of some advantages and some disadvantages. For the advantages, let me highlight 3. Long lifespan, absence of moving parts, and the underground construction, which saves space. There are also disadvantages. I'll also highlight a few. One is that it needs specific technical skills. It also needs a special sealant to make sure that it's gas tight. And another disadvantage is the fluctuating gas pressure depending on the volume of the stored gas and its use. A second type is the floating drum digester. You see this in this picture. It has similar features: the inlet, the digester for the slurry, the outlet, and the overflow. But here now, the gas holder is not a fixed unit, but is a moving unit. Here it's floating on a water jacket. In some cases, it could also be floating directly on the slurry. With increasing gas pressure, this floating gas holder moves upwards, and when gas is used, the weight of the drum pushes it back down. The gas drum is typically made of metal, painted to protect it from corrosion. It can also be made out of fiberglass, reinforced plastic, or galvanized sheet metal. In this design, there's also a guiding pole to make sure to stabilize it while it's going up and down. There's also a divider wall, which helps to avoid short-circuiting of the slurry from the inlet to the outlet. You see it here. The digester is often placed below the ground, while the gas holder drum is above ground. Here is an example of such floating drum digesters from India, with the metal floating gas holders. Or here another, also from India. Here are examples of small household units made out of fiberglass reinforced plastic. The brown part on the top is the floating drum. Or here another example from Tanzania, made by using the typical water tanks out of plastic and some plastic piping. Here are some advantages and disadvantages of the floating drum reactors. Advantages are that it's simple and easy to operate. One big advantage is that the volume of gas is directly visible, and that means we know if the system is working or not. We also have constant gas pressure, or we can increase this pressure by adding some weight onto the gas holder tank. Some disadvantages are the high material costs for the steel drum, and that these steel parts are susceptible to corrosion. There are also regular maintenance costs that arise from keeping this corrosion at bay. The third digester type I would like to show you is the tubular digester, like this one in Costa Rica. These are quite common in the Latin American region. These are long, horizontal lying tubes or balloons made out of plastic and rubber. The inlet and outlet are attached directly to the skin of the balloon. You see this here in a schematic. The balloon, the inlet and the outlet, and the gas pipe on the top. These balloons usually need some protection from the top as well as from the bottom. What we usually have is a compacted backfill. Some advantages are low construction costs, very simple to install, easy to construct, but some disadvantages are a relative short lifespan and susceptible to mechanical damage. So, those were the three types of technologies that I wanted to share with you. There are a lot of variations in design. For instance, this combination of a fixed structure for the digestate and then a balloon for the gas storage. This is an example from Germany. Why don't you share with us what kind of systems you might have encountered in your region or during your travels? Submit them into our forum. So let me summarize what we covered in this module. We looked at 3 different types of digesters. We looked at their design features and some examples. For each, we listed some advantages and disadvantages. In the next module, we'll focus on maintaining the digester in operation and at the product chain, the gas and the digestate. Thanks very much.
Ok, está lloviendo, hace frío, hace 39 grados y vengo a mostrar cómo está el árbol para que vean las hojas. Es increíble cómo este árbol está, a pesar de todo el frío que ha sufrido durante esta semana, está por nevar y miren las hojas cómo están, es increíble, tiene un vigor este árbol, es impresionante. Pero quiero mostrar en Reading la fecha, ok, está lloviendo, 39 grados y va a llegar a ser hasta 28 grados, así que está pronosticado nieve, está nevando por todos lados y para que tengan idea de cómo está esto, este árbol que está acá al lado también es un árbol de naranja que yo planté. Y también lo planté con el sistema de lenguaje. Miren cómo está, es impresionante. Súper verde, saliéndole hojas todas nuevas, así que es algo increíble.
Hermanos, aquí estamos mirando algo espectacular. La hermana Juay dice que una finca tiene que tener agua y cuando hay agua es como oro. Y aquí tenemos una gran cantidad de agua. Pueden ver, mis hermanos, de que la propiedad está a nuestra izquierda de la grabación. Ahí arriba está la tierra que estamos procurando comprar y esta parte del río corta una punta de la propiedad, así que podemos colocar una bomba y desde aquí con tubería llevar el agua para las plantaciones. Tenemos agua todo el año y como podemos ver es una agua limpia, no es una agua turba, sucia, una agua limpia que podemos aprovechar. Y estamos muy contentos porque la carretera pasa a la izquierda, pero el río pasa dentro de la propiedad, así que estamos con una bendición muy grande, que es tener agua todo el año para la agricultura. Vamos a orar para que pronto podamos comprar este mes esta propiedad y vamos a tener acceso a toda esta agua, parte del pozo que ya miramos y de los otros pozos que podemos abrir al futuro. Que Dios lo bendiga y que el Señor pueda tocar nuestro corazón para que pronto podamos tener este lugar como nuestra casa y aquí iniciar la obra del Señor al norte de California. Un gran abrazo, Dios lo bendiga.
Bueno, estos son los tanques que estamos haciendo aquí en casa. Son unos tanques que se usan para la pintura o para traer aceite o todo lo demás. Yo los conseguí vacíos muy económicamente, como a $5 cada uno, porque se los querían sacar de encima. Entonces armamos esto para poder hacer el gas aquí adentro. Entonces, bueno, esto es muy parecido al otro. Consta de un garbage disposal que lo hicimos con una maceta también, ¿ok? Una maceta vieja. Y entonces lo que vamos a hacer es introducir toda la comida por aquí y va a ir hasta el fondo, ¿ok? En el fondo está cortado a 45 grados, como se puede ver. Creo que por ahí se puede ver mejor, pero bueno, está cortado a 45 grados. Ese extremo y este extremo va a salir el gas, ¿ok? El gas, este tubo va derecho hasta abajo, hasta el fondo, y está agujereado más o menos como a los 4 o 5 centímetros o 2 pulgadas, ¿ok? Tiene un agujero pasante de lado a lado y un agujero pasante del lado a lado para que el gas suba, pase por aquí. Entonces va a ir al filtro de agua, ok. Yo conseguí un filtro que se usa para filtrar agua. Bueno, entonces lo que hace, entra aquí al medio, burbujea y de ahí sale. Le tengo que poner un pedazo de pipa de cobre que va en el centro para que burbujee, y el agua, esto es para que no pase ninguna suciedad ni nada. Entonces de aquí va a pasar al filtro, el filtro que va a llevar este material, okay, que se llama lana de acero o steel wood. En Argentina lo conocen como virulana, okay. Así que el material, como podrán ver, es como si fuera una lana, okay. Es como una lana bien finita. Lo que hace esto, al estar lleno, no tan comprimido, bastante suelto, como que para que pase el gas, se filtre, y lo que produce es que le saca el olor y todo lo demás. Entonces de aquí va a ir a unos tanques que son como unas bolsas, ¿ok? Que las voy a poner en internet ahí para que ustedes lo miren. Y bueno, ahí lo vamos a concentrar, y lo que vamos a hacer es llenarlo con comprimirlo en un tanque. Entonces ahora voy a mostrar eso también en un ratito. Por aquí sabemos que va a salir el biofertilizante, ¿ok? Esto también tiene un agujero más o menos a la mitad del tanque, tiene un agujero ahí. Y bueno, a ver si se puede ver más o menos. Sí, ahí está, ¿ves? Ahí se puede ver más o menos los agujeros. Entonces, bueno, lo vamos a llenar con estiércol de vaca primero y nopal. Otra cosa es que lo vamos a pintar de negro. Y también en invierno que hace mucho frío. Entonces, como hace mucho frío, le vamos a poner un panel solar y un calentador para que caliente el agua y produzca gas mucho más rápido, ¿ok? Si no, lo tenemos que cubrir completamente. En realidad le tiene que dar calor a esto para que fermente y se produzca el gas. Así que por eso los vamos a pintar de color negro, ¿ok? Durante el día le va a dar sol, como ven. Acá está en un área que está todo abierto, no hay nada de nada, entonces el sol le da directo. Entonces se produce mucho más el gas. Esta es la otra forma, ¿ok? Si uno necesita hacer gas en gran cantidad, se puede hacer de esta forma. Nosotros vamos a hacer en estos dos tote o containers. Este es otro que lo estoy armando. Yo lo traje así nomás, pero porque lo traje de donde yo estaba viviendo en Loma Linda. Así que lo voy a terminar, lo voy a cortar. Esto está todo flojo, se saca, así que está todo postizo nada más. Solamente, como vieron el caño, yo lo dejé así alto, después lo tengo que cortar a medida. Y bueno, voy a hacer exactamente lo mismo y voy a unir este con aquel en la misma línea de gas para que produzcan los dos bastante gas. Entonces lo que vamos a hacer también, le vamos a hacer una escalera acá y una plataforma como para poder subirse y poder con el garbage disposal poner la comida y triturada, ¿no es cierto? También se puede poner a mano. En el otro yo lo puse a mano, así que y funciona igual. Lo único que uno tiene que tener es un pedazo de metal o algo, un palo para poder empujar un poco la comida hacia adentro, que sea más fácil de ir. ¿Por qué? Porque es un poquito más grande. Entonces, lo que tiene que esto, cuando entra el agua, lo deja casi líquido. Entonces es mucho más fácil que se vaya para adentro, porque está totalmente desmenuzado, casi prácticamente líquido. Entonces no voy a estar necesitando estar empujándolo. Así que esa es otra cosa que hay que ver, ¿no? Que hay que estar siempre atento, que no se tapone ahí, hacer que la comida entre dentro del tanque. Más que todo en los chicos, no en los grandes. Y si tiene un garbage disposal, no va a necesitar tampoco, porque el garbage disposal lo que hace es triturar, lo deja casi hecho agua. Ok, esto es lo otro que yo estoy por probar. Este es un compresor que comprime hasta 4000 psi. Entonces el gas lo hago entrar por este nipple de aquí, ok, del tanque, va aquí. Entonces comprime el gas y lo manda al tubo. Y el tubo yo lo conecto a la línea de la cocina y tengo el gas comprimido, como si fuera GNC o como si fuera el gas natural, ¿no es cierto? Nada más que uso el biogás, ¿ok? Como verán, esto tiene una entrada y una salida de agua, tiene una bomba que yo la pongo en un tarro con hielo y entonces chupa el agua fría, la manda por aquí y la devuelve dentro del tarro. ¿Por qué? Porque es tanta la temperatura que levanta de la compresión que hace, porque son 2000 psi que que carga, que calienta muchísimo. Entonces yo aquí tiene un pequeño reloj donde yo le puedo regular la cantidad de PSI que yo quiero que entre adentro del tanque. Ok, si quiero 1000 nada más o 2000, yo no le cargo más que 2000. Y bueno, esto yo lo uso también para un montón de cosas, para poder llenar aire a las ruedas del auto, o para nosotros tenemos unos rifles de aire comprimido que son especiales para el área de acá, entonces no se necesita tener licencia para eso, y nos ayuda a que si hay una víbora o lo que sea, vienen con unos cartuchos especiales para poder matarlas más fácilmente. Las cascabeles son bien difíciles y se escurren bien rápido, entonces la forma más fácil es esa. Bueno, entonces nosotros pensamos usar esto mismo en el gas, conectarlo, viene con un... ahora voy a mostrar. Le ponemos un regulador, ¿no es cierto?, que da la presión que nosotros queremos. Entonces de aquí sale a la cocina que nosotros usamos, y de aquí va a entrar el gas de acá. ¿Ok? Entonces esas son las cosas nuevas que estamos trabajando y estamos haciendo. Ahora voy a mostrar también lo de para calentar. Esto es para calentar. Es de 48 voltios, o sea que funcionan con paneles solares. ¿Ok? Para hacer funcionar necesitan 48 voltios, así que necesitarían dos paneles. Estos paneles son grandes, son de 250 watts cada uno, entonces producen aproximadamente como 40 y pico de voltios cada uno. 30 voltios cada uno, ahí está, 30 voltios más o menos cada uno, así que necesito unir dos de estos para que pueda funcionar esto. Entonces esto lo vamos a usar en dos lugares. Lo vamos a usar en el greenhouse con un water heater para calentar agua y poder calefaccionar el greenhouse allá. El greenhouse lo vamos a calefaccionar con este tipo de aparato para que tenga la temperatura de adentro adecuada, siempre la misma temperatura, para que se puedan cosechar todas las cosas perfectas. ¿Ok? No haga frío ni nada. Y también lo vamos a poner con otros dos paneles en uno de los tanques que están aquí. Lo que vamos a hacer en este tanque es hacer una pequeña perforación. Entonces vamos a poner este sensor con el calentador adentro del tanque para que caliente el agua. ¿Ok? Y le vamos a conectar el panel solar, un positivo y un negativo, así que llega a la temperatura y se corta automático. Ok, tiene un relay, así que 48 voltios, a ver, 100 watts. Este lo pueden conseguir en Amazon o alguno de ellos, ¿viste? Así que esta es otra posibilidad para que produzca mucho más gas. Hay muchas cosas que se pueden hacer para que produzcan más gas, pero lo más importante es que usen el estiércol de vaca, que es lo ideal, con el nopal. Son las dos cosas que producen más gas de todas las cosas vegetales que hay. De todo lo vegetal son los dos que producen más gas. Otra cosa que quiero recordar, que los paneles solares dice 35 voltios, pero no es lo que cargan 35 voltios, cargan mucho menos siempre. Aparte depende de las horas solares, ¿ok? Si los paneles solares tienen un sensor o tienen un seguidor del sol, un tracking, es mucho más fácil porque va a estar cargando todo el tiempo a la misma tensión, ¿ok? Pero si ustedes los dejan fijos, no va a estar cargando a la misma tensión. Entonces es bien importante mirar de dónde sale el sol y dónde se oculta el sol, y poner los paneles solares correctamente, como para que si lo van a poner fijo, la hora del mediodía es la hora ideal. Entonces tienen que mirar más o menos el sol donde va a estar al mediodía, y entonces lo colocan, ¿okay? A 45 grados mirando hacia el sol. Otra cosa, en invierno va cambiando, el sol se va corriendo, así que tienen que buscar un lugar que realmente les dé el sol todo el año, invierno y verano, ¿ok? Nosotros tenemos como 40 paneles solares, y los 40 paneles solares, yo algunos los tengo ahí al lado de casa, los tengo postizos ahora porque los tengo que poner en otro lado, en la huerta. Y entonces el sol, ahora estamos en otoño, se ha corrido y no le está dando. Así que los tengo que poner de una forma que le estén dando todo el año, si no, no sirve de nada. Bueno, les voy a mostrar otra cosa que se puede usar con los paneles solares. Es un Solar Tracking Control, ¿ok? Entonces lo que hace esto es que esto sigue el sol, ¿ok? Esto se pone abajo del panel de los paneles solares, ¿ok? Este es el sensor que sigue el sol, que busca el sol. Es el sensor que continuamente está buscando el sol, ¿ok? Entonces se pone esto en el medio de los paneles solares. Entonces si el sol va hacia al este, empieza del este, ¿ok? Y va moviéndose de acuerdo a cómo se va moviendo el sol, y cuando bajó el sol, vuelve de vuelta al mismo lugar. Esto funciona también con una batería que tienen que tener, ¿ok? Para poder moverlo, y un panel solar de 100 watts para poder alimentarlo. Y este es el que mueve los paneles solares, ¿ok? Lo mueve para un lado y para el otro, ¿ok? Se engancha aquí abajo, se engancha ahí, y este cable que está acá se conecta a la computadora, que es el sensor, y lo mismo esto, ¿ok? Entonces va buscando el sol, y entonces continuamente está teniendo la misma potencia de los paneles solares.